Okay, here's the problem solving video for learning extension 2.11, which is a single node pair circuit, and we'll be utilizing the problem solving strategy on page 41 for single node pair circuits. Step 1 says to find a voltage between the two nodes in the circuit, and so we will pick a polarity, and I'm going to assign the polarity as such and define that as voltage V1, and I will assume that the top node is at a higher potential than the bottom node, and we'll call that bottom node the reference. Step 2 says using Ohm's law, define a current flowing through each resistor in terms of the defined voltage. So for this resistor we would have V1 over 4K. Okay, for this resistor we'll have V1 over 6K, and for this resistor we have V1 over 12K. So now we've completed step 2. Step 3 says apply KCL at one of the nodes, or the two nodes. Let's apply KCL to the top node, and let's sum currents leaving that top node and set them equal to 0. So if we start on the left, we'll have a current of 6 milliamps leaving. This current's leaving, we'll have V1 over 4K. This current's leaving, we'll have V1 over 6K. This current's entering, the equivalent current leaving would be minus 4 milliamps. And then for this current leaving, we'd have V1 over 12K, and that's equal to 0. So there's our KCL equation. Now we need to solve that for V1. Once we have V1, then we can calculate the power absorbed by that resistor. So collecting terms here, we'll have V1 as 1 over 4K plus 1 over 6K plus 1 over 12K, and that's equal to minus 2 milliamps. If we multiply through by 1,000, we'll have V1 as 1/4 plus 1/6 plus 1/12 is equal to minus 2. And if we multiply through by 12, we'll have V1 is 3 plus 2 plus 1 is equal to minus 24. 6 V1 is minus 24. Therefore, V1 is equal to minus 4 volts. Okay, now, let's think about the implication of that answer. V1 turned out to be minus 4 volts. And you notice that when I assigned the polarity to this problem, I selected the top node to be a higher potential than the bottom node when I assign that voltage. When it turns out that V1 is equal to minus 4, that says that the bottom node is actually at a higher potential than the top node. That's what that minus 4 indicates, that the bottom node is actually at a higher potential than the top node. Now, to calculate the power, remember for power, we can have, in this case it would be V1 squared over 6K. We're going to use P is equal to V squared over R. So then the power is minus 4 squared over 6K, and the power then is 2.67 milliwatts. It doesn't make any difference in calculating the power because we've got V squared.